Hello! Welcome to the video series on programming with Python and R. In this video, we'll be talking about if-else statements. So in the last video, we talked a bit about flow control, and flow control is any command that determines which code gets executed next. So if you don't want your code just to be executed one line after the other, but you want to be able to do something repeatedly, or maybe not a certain chunk of code doesn't get executed at all under certain circumstances, that's what flow control does. So last time we learned about loops, so that if we have a piece of code that we want to run repeatedly, we can run a loop to do that. And so this time we'll learn about if and else statements. So an if statement will test a certain condition, and only if that condition is true will it execute a certain chunk of code. And optionally, with an if statement, you can add in an else statement to give code that should be executed otherwise. So it's kind of like if my husband's going to the store and I want some yogurt, and I say, well, if they have coconut yogurt, get that one, otherwise buy peach yogurt. Now he's been given sort of two sets of instructions, and he's been given a condition on which to execute them. And he will love that because he's also a programmer. But anyway, so usually if you're just writing a script that you're only going to run once, you don't put an if-else statement right in that script because you already know what you're going to do. But if you have a loop where on certain iterations of the loop you might want it to behave differently, that's a really good place to use if or if-else. Or in a function body where you need the function to behave differently under certain circumstances. Or maybe if it's a script that you're going to run a bunch of time with different inputs to it, you might also have if-else. But it doesn't make sense for it to use if-else if it's just something you're only doing once. So the learning objectives here, we're going to talk a little bit about more about Boolean values, which are values that are true or false, particularly different ways that we generate these. So comparison operators like less than or equal to. There's an operator called in that determines if a certain value can be found within a set or not. And there are a lot of different functions and methods that return true or false. So you're also going to learn how to use if, else, and elif, which is short for else if, to perform flow control using those Boolean values. And then we're going to learn some Boolean operators like and, or, and not, which can be used with Boolean values, not kind of being, not switches true to false, and or are if you have two different expressions and you want to do something with both of them together. As a reminder, you can look in the description for a clickable table of contents if you don't want to watch this whole video at once, or if you want to skip back to sections that you would like to rewatch. And although I'm teaching both Python and R in this video, I recommend that you actively follow along with just one of those and then passively watch the other one to get a feel for it. So here's the website where you can get the files that we'll be using today, and there is actually also a link to this in the description. So we have these two FASTA files, and this is EPSP synthase, which is the target enzyme for the herbicide Roundup, and also the gene where certain mutations cause Roundup resistance. So if I click on this, remember you're going to want to go to raw, and now you have something. This is not finish. Anyway, I could, in Chrome, I can right click and save this as a text file, or I could copy and paste it into a text file in a text editor. So you want to do that with both of these two files. Right, so I already have saved these two in this folder, and this is the folder where I'll also save my scripts for today. So as usual, let's start out with a demo in Python. So I'm actually going to open up one of the files that I just downloaded so I can copy and paste some text from it to do some operations with. So I can open that right in Thonny because it's a text editor. So let's grab this first line of text. and I'm going to put it in quotes here. Right, and so let's call this DNA. And I'll save this as my script. I'll call it Boolean intro.py. So I can test the length of this DNA string using the len function. So let's see what happens if we get that length and then print it out. Right, so this is 100 nucleotides long. So I want to know, is this equal to 100? And let's print out the result of that. So here, 1 equals sign assigns this value to this variable name. 2 equals signs right next to each other, no space, tests if these two things are equal. And so I get the output of that, which is true. If I put an exclamation point and an equal sign, again with no space, that is not equal. So here I'm testing, is the DNA length not equal to 100? And that comes out as false. So we also have greater than, we have less than, we have greater than or equal to, and we have less than or equal to. So, oh, there's my mistake. I did that with DNA instead of DNA length. And so I was comparing this text string to a number and it said, that's not right. So you can't do less than or equal to between a string and integer. Okay, so yes, DNA length is equal to 100. No, it's not equal to 100. True, it's greater than 50. False, it's not less than 50. False, it's not greater than or equal to 300. True, it is less than or equal to 100. So just to check this out and see how it's working, I can take one of these shorter lines and try it with that. So here I'll comment this one out. And I'll put this other one in. So that one was 28. So we get false for it being equal to 100. We get true for it not being equal to 100. We see, yeah, it's less than 50. It's less than 100. Okay. In addition to comparison operators, there are a lot of functions that return true and false values. So let's take a look at this first comment line. Right, so maybe we want to test if something is a header line like this or a DNA line like this. And every header in a FASTA file starts with this greater than symbol. So I can say, and again I'll print out this expression just so I can see the result of it. Header starts with, and then type in that symbol. So remember in Python, this is how methods work, where you have the object and then a period and then the method that you want to use. So starts with is a method for character strings, and I'm putting in this character that I want to see if it starts with. And before this, let me just print out something else just so in the output I can see that this is separate from my comparison operators. All right. So I'll run that, and I see, yes, I get true. That header does start with that less than sign. I could do the same test with my DNA string. And I'm going to get false, that the DNA string does not start with that greater than sign. So now let's take a look at the same thing in R. I will set up a project for this folder. Right. So there are my two files. I forgot and I put my Python script in the wrong folder, but that first script, it's okay. That one won't read any files yet. So I can also open these files right in here to use them for copying and pasting for some code. So I'll make a new R script, and we'll do the same thing again. So let's say DNA will assign this first string here. And I'll hit Control Enter to run that. To get the length of that, in R, the length function only gets vector lengths. If you want the number of characters in a string, you use nchar. And we see that is 100. Right, and this little L shows up here to show that it's an integer, but that doesn't matter for what we're doing. All right, and so all of those comparison operators in R, they're exactly the same as they are in Python. And you'll notice in Python it was just the T in true that was capitalized. In R, it's the whole letter. That's really important if you're ever typing these out. Right. So we have not equal. Right, that's false. It's true that it's greater than 50. False, less than 50. And just like before, we have the less than or equal to and greater than or equal to. And like before, I can try that out again on a different, yeah, we'll try it on a shorter piece of DNA just to see that it works. So we'll comment out this one line, make a new one. Remember, you have to run that to actually change what it is, and you'll have to run this nchar again to change this from 100 to 28. And now if I run all of these, right, I see that now they're all adjusted for that DNA sequence being 28 nucleotides instead of 100. And I'll save this one. Okay. And in R, we also have a starts with function. Yeah, so we would put first the thing that we're testing and then the thing that we want to see if it starts with or not. So again, I'll make that header. And then if I say this header starts with header, oh, I forgot to actually make my header. The dangers of R is you can forget to execute things. Right, and so this confirms, yes, that header line starts with that greater than symbol. can test my DNA string. It does not start with that. Okay, so what I want you to do for an exercise, and this will work either in Python or R, there's a function called any and a function called all, and I want you to look those up and see what they do and give them a little try. Okay, so let's look at the documentation in Python for any and all. Okay, here they are. All right. So all returns true if all elements in an iterable are true. And any returns true if any element of an iterable is true. All right, so what's an iterable? Well, we learned about lists, and that's one example. So let's take a look with lists. So say we make a list, and we're going to put in just true and false values. And actually, let's make a second one that is all true. And one that's all false. And let's see what any and all do with these. Right, so it's true for test lists. So because some of these were true, the any function returns true. But not all of them were true, so the all function returns false. And we can see how that works with the other two lists as well. So with all of them true, both any and all return true. And then if they are all false, any and all return false. So in Python, you maybe would work like with a list comprehension. Say, let's have a list of some numbers. And you might say, let's print it out, print any, and then we could say I is greater than 4 for I in some nums. And so this will say, are any of these greater than 4? And that's true because the number 8 was greater than 4. But if I check, are they all greater than 4? That's going to be false because some of them weren't. Right? And these functions work exactly the same in R, except in R it's a little bit easier to construct something like this. So say any right? That's true. But if I did all, this is going to come out to false because not all of those were true. So I could say some nums are 2, 3, 4, and 8 again. I could say, and if I do some nums are greater than 4, again, I need to actually make that vector first. Right, so it's going to put in true and false for everything in that vector. Right, I don't have to do a comprehension like I do in Python. So then I could take that and I could put it inside any to see if any of those were true. And I could put it inside all to see if they're all true, which they aren't. So lastly, I told you I was going to show you an operator called in. And so this is for testing if a particular value is within a set of values. So let's make a set of values called ACGT here that are the letters A, C, G, and T. And in Python, a shortcut for doing this is the set function. And if we type in one string with those characters, it's going to actually convert that into a set where each character is separate. Right, so there's our set. And we could have also typed it like this to construct it. That's another way you could do it. So if I want to see, is the letter C in that? And maybe test if the letter Q is in that. Right, so this should be true and this should be false. And maybe I want to take my entire DNA string and confirm that everything in there is an ACGRT. So I can actually do a list comprehension across characters in a string. In fact, let me just print that out to show you. Right, and then so I could say D in ACGT for D in DNA. And then maybe I want to do all with that to confirm that the whole thing is ACGRT. And that's true. And there's a slightly more Pythonic way to do it. The same task. You can do all sorts of stuff with sets. So I could take set DNA is less than or equal to ACGT. So that's comparing two sets. And that shows that everything in that DNA string is an ACGT. But that is a little sidestep from the concepts that I'm showing you right now. Right? But anyway, I could take the same one, and if I want to say, okay, is everything in the header ACGRT, that will give me false, right? Because that header is not a DNA string, it's got a bunch of other characters. Right? And so we also have an in operator in R, but in R we're going to put these percentage signs on either of it to distinguish it from the in that we would use in for loops. In Python, it just uses the context to know what you mean with in. In R, you need to actually distinguish it this way. All right, so and in R, we'll make ACGT, we'll set that up as a vector since we don't really have sets in R. Right, and so C in ACGT, so that's true. If we look for the letter Q, that's going to be false. And if we want to split our DNA string into its component characters to test them, we can use the string split function. And I'm putting an empty string there as the split to split it into all of its components. Now because this is vectorized, it returns a list where the first item in the list is the first string split up, but since I only gave it one, I'm going to put this double brackets and a 1 after that to just get that first element of the list, which is what I want, which is that DNA string turned into a vector. So I can see, are all of those in ACGT? It's true for all of them, so I could use the all function to test that. And I could do that with the header to see that that is not a DNA string. Okay, now that I've showed you all sorts of ways to generate Boolean values, now let's finally get to what this video is supposed to be about, which is how do you use them in if-else statements. So we'll build a practical example here. Right, and this time I'm going to make sure I save this in the right folder because it is going to read those files. So we'll call this read FASTA.py. Okay, and we're going to build a function here. So recall in Python we use the def command to build a function. And we'll use the letter F to stand for a file. Okay. So if you recall, for opening files, we'll use with open F in read mode as, and then we'll make the file connection there. And then in Python, we can loop through lines in the file. All right, so now we're ready to say, okay, what do we want to do with each line? So as you recall, this FASTA consists of multiple DNA sequences, and each one has a header line. So we want to know, do we have a header line or not? So we can say if line starts with and then we can say, okay, here we're going to do stuff with header. And I'm going to put in this keyword pass in Python. Usually I don't leave code with pass in it, but that just is sort of a placeholder that says do nothing, which lets me get out of this if statement. All right, and then if it doesn't have that, then I want to do something with my sequence. So here I've kind of set up what I'm going to do. All right, another little boilerplate thing. In Python, if I read it like this, it's going to hang on to the new line character at the end of each line. I don't want that. All right. So let's say we want to gather up our sequences and our headers. So we'll set up both as empty lists. Fix that typo there. And okay, and another thing to note is that a lot of the sequences take up multiple lines. So I'm going to make this variable that's just a character string that I'm going to use for building my sequences and then sort of resetting it once I get to a new header. Okay, so if I discover that I have a header, I want to add that line to my list of headers. In fact, let me just right now say that what I want to return is a list with my headers and my sequences. And if I have a sequence, I want to add that sequence onto whatever I have for my current sequence. right? But how do I know I've gotten to the end of a sequence? Well, I know that when I hit a header, then I know that I've gotten to the end of a sequence. All right, so I'm going to say sequences append the seq, and then I'm going to reset what I have so I can start again with building that sequence. Okay. So then let's try this function out. And since I am writing this on the fly for this video, it might have errors, and I'll try to debug them for the video. Unless they totally stump me. Alright, so I'm going to put in my file name. And again, make sure the file and the script are in the same folder for this to work. And I'll just print out the output so I can see what I get. Alright, so that worked, although for some weird reason it hung for the first time I ran it. If it hangs for you, just press stop and try it again. Alright, so a couple little problems here. Alright, so our headers read in just fine. As you might have surmised from looking at the code and thinking about it, the first time it gets the first header, then it's just adding nothing to the list of sequences, this empty string. And we'll also need to add the last string to it. So if I look in here, yeah, like this last one is actually the second to last. So we can fix that first part by, or we can fix having a missing sequence by just adding on that last sequence at the end right here. Right, so when it gets to the end of the file, oh, actually, right there. So after it's done looping through the file, after the for loop is run, then we'll append the sequence. All right, so we can check and see, okay, that part got fixed. We still have an empty sequence at the beginning, and that's going to be your exercise, is figuring out how to get rid of that. So let's do the same thing in R. We'll make a new script. And again, we'll call it readfasta.r. All right, so to make a function in R, we'll use the function keyword, and then we'll use curly brackets to put in the body of our function. All right, so we'll just read all the lines at once. We won't need to remove a new line character. And then we can loop through those lines. And we'll set up the same vectors. Well, in Python they were lists. Here they're going to be vectors. So we'll set those up empty. And we'll also set up an empty string to contain sequences. And basically now the rest of this is going to work in the same way. So we'll say if starts with line. So in Python, right, like a lot of other things, we were using a colon and then indentation for our if-else statements, kind of like we did with for loops. In R, again, like we do with for loops, we're going to use these parentheses and curly brackets. So here we'll do stuff with header else do stuff with sequence. Right? And it's, for good form, I always put the else on the same line as the closing bracket of the if statement. I've seen people get away without doing this, and I think whether it works or not depends on the context, but because R tends to evaluate things one at a time, if you have this all on the same line, it shows R that you aren't done with your command yet. Alright, so in this case we'll add the line to the headers. We'll build on our sequence. Right, and then we'll want to add in the sequence to our vector of sequences. Right, and then we'll reset what the sequence that we're gathering is. Alright, and again we're going to, one last time after the loop is done running, we'll add in the last sequence. Because otherwise, if we're only adding sequences when we hit a header and we have the last sequence without a header after it, it wouldn't get added. And then we'll return those two things in a list. Right? And we can test this out. Okay, so I will send my function in. And I get a warning, I think because I didn't have a new line at the end of my file. But in any event, I can look at what we got. So we have, here's our vector of DNA sequences. Again, we have this empty one at the beginning. And we have our vector of headers. And let's just double check that the last sequence looks like it should. All right, that's CTG ends with CAT. Yeah, that looks like our last sequence. Okay. So for your exercise, and do this either in Python or R, I want you to use another if statement somewhere. You won't need an else with it, you'll just need an if to modify the behavior of this function so that you don't get this empty sequence at the beginning. So get rid of this part. Or if you're doing it in Python, get rid of this part. And do that with an if somewhere within that for loop. Okay, so there are probably multiple right answers to this exercise, but here's one that I would do. Right, so these two lines really, so they don't need to happen for the first header because there was no sequence before the first header, but they should happen every time after that. So I just need a way to test, is this the first header or not? And so I'm adding this line to the headers list. The first time I do that, then I know that list is only one element long. So I could say if the length of headers is greater than 1. And then I will indent both of these lines so that they happen within this if statement, right? So I'm saying only do this part after the first header, right? Don't do it before. In fact, I suppose this would also work, and then I wouldn't need this part. Although well, that could be a good thing, because that could also mean that if the file doesn't start with a header and it just starts with a sequence, I'll get an error right here. But that's okay, because it should always start with a header. All right, so let's try it. Let's see how that modified one works. All right, didn't give me an error, which is always a good start. And now I do not have that blank one at the beginning, but I've got all the others. All right, could do the same thing in R. All right, I can scrap this line, and I could say if length of headers is greater than 1, and then I will move this part where I add the sequence to the list inside that if statement. Right, so I will rerun this function definition. I'll read the file again, and now we'll take a look at the output. Great, and now I don't have the blank one at the beginning. Okay, so that works if there are just one or two different situations that you want to choose from, but what if you have 3 or more different possible things you might want to do? For example, a FASTA file can also contain a protein sequence. So maybe I want to test if it has a DNA sequence, an RNA sequence, a protein sequence, or something else, and maybe I want it to throw an error. Right, so let's, in this function, add another list that we're going to return, where it's going to tell us the type of sequence each one is. And actually, rather than trying to nest more stuff in here, once we've read the file, let's make another loop where we loop through that sequence output to fill in the sequence type. Right, so here we're going to loop through those sequences and do some tests on them. And before, you'll recall, in fact, I'll set these up ahead of time too. So we have ACGT is our set of potential letters that we might find in a file with DNA sequence or in a string with DNA sequence. Let's make one for RNA. And for amino acids, there are 20. I don't want to have to type them all out, so I'm letting myself and you guys cheat by copying them from the GitHub page that I set up for this video. All right, 20 plus this asterisk, which means the stop codon. Okay. So, let's see. I could say if, and since it's Python, I'll use that thing I showed you in the first part of the video where I'm also going to convert the sequence to a set and see if that falls within the set that I made for what the possible nucleotides are. So is everything in this sequence within ACGRT? And if it is, I'm going to say this is DNA. All right, and so I want some alternative. If this isn't true, then I would want to say Is it RNA? So in Python, I can use this keyword elif, which is short for else if. So if this first one was not true, then I'm going to test another one. Right, so now I'm going to test if it's RNA. And if that's not true, that's what I called it, right? Double check, yep. And then if none of those are true, I can put an else. So if none of these three ended up being true, then what do I want to do? And here I'll have it give an error. Okay, so let's test this out first with our DNA sequence. Okay, so it identified all of those as DNA. And then maybe I'll add on, I want to try it with the peptide sequence. So let's try that one out. Okay, that worked. And maybe just for entertainment, or not really entertainment, but let's check and see. Actually, let's see, I can open that again from here and edit it. Let's grab one of these and add something that it's not expecting. Something that's really not expected in a DNA sequence. Ooh, and I guess I did save that. I'll have to fix it again. So now if I run that, I get my exception saying that I had an unexpected sequence. So the error checking works as well. I'll go back and undo what I just changed about this file. Okay, so let's modify our R functions in the same way. I'll set up my sequence type vector. I'll make sure I return it. If I were doing this for real in R and I expected a lot of sequences, I might set this up afterwards and pre-allocate it to make it as long as it needed to be, because it can be slow to gradually build a vector if it's going to be large. But for now, since this is a simple example and that's not what I'm demonstrating, I'm going to leave it like this. Okay, so let's make another loop. Oh, actually, we should make that after we add our last sequence, right? Maybe I'll put in a comment to say what I'm doing. All right, and so we'll also need to define our various types of sequences. It doesn't matter if you use single quotes or double quotes. We'll make one for RNA. And then we'll take that string of amino acids and split it up like I showed you before. right? And if maybe you want to double check this one line to make sure that it would come out right. So normally this wouldn't end up in the global environment because it's in the function body, but my global environment's so small right now I don't mind just sending it in for the sake of checking it. Right, that looks good, and then if I ran this script again, that would not be in the global environment. Okay, so say if all, let's see, we're going to need to split up that sequence into its components, so a split equals right, so now we have our split sequence. So we'll say if all of S split is in ACGT, then we're going to say that it's DNA. So we'll tag the string DNA onto our sequence type vector. And so in R we do not have an elif keyword, but you can just type else if, and it's going to work the same way. All right, and I'll save myself a little bit of typing by copying and pasting this part. And I'll copy and paste this part too. And then I'll do another else if for the amino acids. Why not playing with Kitty right now? All right, and if it's not any of those things, then I want an error. So I'll save that. I'll rerun my function definition, and I'll try it out. All right, so I did get that vector indicating that it's all DNA. I'll try it again with the one that's peptides. And that works too. It identified it as protein. And again, I'll see what happens if I make a modified version of this file. It should give me an error. And there it is. There's the error that I told it to do with the stop command. So I'll go back and fix that again. So what if there are multiple conditions that I want to test before I execute a certain piece of code? I could nest multiple if statements within each other, but that would get pretty awkward. So instead we're going to use keywords like and, or, and not. So I'm going to add some code down here to demonstrate those. So and tests if both of two conditions are true. So the only thing that should be true out of these three is true and true. If anything is false, then the whole thing comes out to being false. Right, so this first one is the only one that comes out to being true. So it works like that word works in a normal English sentence. The or keyword will be true if any of two conditions are true. So either if they're both true or if just one is true. So maybe that's slightly different from how you would use it in the English language. But I'll demonstrate here how it works. Right, so both of these first ones come out to true. This is the only one that is false. And not switches true to false and false to true. Right, so this true got turned into a false, this false got turned into a true. So let's say what I want to accomplish is testing in that DNA file, just looking at the introns, and for each intron seeing, is it a normal intron that starts with a GT and ends with an AG? So let's make a function to do that. I'm going to delete these parts. You can always rewind if you want to look at them more. Okay, so I'll call that function examine introns, and I'll have it take the output of the previous function as its only argument. And I'll just remake those headers and sequences variables. Just to make the code easier to read. Let's see. So we're going to loop through the sequences. Actually, we'll make another variable that's how many sequences we have. And then we can loop through an index for the number of sequences. Right, so this range function will create a series of numbers starting at 0 and ending at the number of sequences minus 1. So that lets us loop through each header and each sequence. So how do I construct this expression? So I want to say if. So I want to test if a particular header has the word intron in it. And because Python is so text friendly, I can say intron in headers I. So, right, this retrieves this particular header for this particular sequence that we're looping through. And then this will test if the word intron can be found within that header. Okay, and then I want to see not just if that is true, but then is it a non-standard intron where it doesn't start with a GT and end with an AG? Say and not. So let's start a new line here just because this is going to get kind of long. Sequences I starts with GT and sequences I ends with AG. Oh, I need one more parentheses there. Okay, so this is kind of a complex statement, but let's break it down. So I can use parentheses to specify order of operations for and, not, and, or, the same way I could use parentheses to specify order of operations if I was doing math. Right, so I'm testing, does the sequence start with a GT and end with an AG? And then I have not to flip that from true to false. So I want to look at cases where both of those things are not true. Right? At least one of them is not true, is what I'm looking for. Right? But I only want to look for that in introns. And to keep this simple, well, no, I will make an output for this function. Say out is an empty list. Say out append non-standard intron else out append xon or normal intron. And then I want to return that output. And so I'll run that on the output of using my read FASTA function on that DNA file. Ooh, I might need to have a backslash here to show I'm not done with the line. So we see in this case that we had all normal introns, but if we go and, say, deliberately change one of them, let's try this again. Now it found that non-standard one. Okay, so let's look at the R version of this. All right. Okay, so in R, our operators are going to be a little bit, they're going to be written differently. They're going to work exactly the same. So for and, you're going to use two ampersand characters right next to each other. Right, so that's true, that's false, that's false. Or you're going to use two pipe characters next to each other. Sorry, starting to come down with a cold, trying to get this done before it, really prevents me from talking. Right, so true or true is true. True or false is true. False or false is false. And for not, we're going to use an exclamation point, just one of them. Actually, technically, I can use a space here. Right, so that flips false to true. Now, if you've used R a little bit, you might be giving me a weird look right now because you're like, wait, people taught me to do it like this, and this works. Why are you telling me to type two of them? So in R, the single ampersand and single pipe, those are the vectorized versions. So if you have a whole vector of true and false and you want to compare it to a whole other vector of true and false, those ones will do it across the whole vector and give you a logical vector as the output. But if you're using an if statement, the double ones are preferred. The double ones will only give a single value. And more importantly, the double ones will, and it works this way in Python too, by the way, it will stop evaluating as soon as it has enough information to know what the output is going to be. right? So if, like, so for example, with this and statement, as soon as it hits the first false, it doesn't even bother evaluating the second one. And with or, as soon as it hits the first true, it's not going to bother evaluating the second expression. And this can be handy if say the second expression might cause an error if the first expression wasn't true. That's kind of why it's handy. So it's good form to use the doubled up ones if you're working with if statements. Okay, so now let's build the same function that we just built in Python. All right. So we're gonna grab our headers. And we're going to use these double brackets because FASTA out is a list, and if you just want to get one thing out of a list in R, you need double brackets. Right, and we'll do nseq is the length of sequences, and out we'll make as an empty vector. So if you want to loop through an index in R, we'll say I in 1 colon nseq. So this will give us the series of integers from 1 to the number of sequences. We'll use our curly brackets and say if. So we want to know if the word intron is within that sequence. In this case, I think the most straightforward way to do it in base R is to use grep L. You can look up this function if you want to know more. Basically, it's going to give you true if it finds a particular string within a particular string, and false otherwise. It does a lot of more fancy stuff. In fact, well, look up the help page to make sure I'm getting the arguments in the right order. Oh, no, the pattern comes first. So the pattern I'm looking for is intron. And I'm looking for it within sequences. All right. And then, and I'll go to a new line, not, and then I have my two conditions. Starts with right, and okay, here we put the sequences I first and then the prefix. The prefix we're looking for is GT. And, oh, not right there. See, I used indentation there to realize that I had put my parentheses in the wrong place, right? Because it put me down right under here, like I was continuing starts with. But I wanted it to go here because I'm continuing what's in these parentheses that I'm using just for order of operations. Oh, yeah, and I used equal signs here for the sake of time. I won't change it. They still work in R. Right, and then I want to return that vector that I just created that's telling me if it found a weird intron or not. All right. So I'll run that function definition, and I'll use it on that first, the DNA file that was normal and everything it found was normal. But if or did I forget to fix? Yeah, I forgot to fix this after I was done anyway. So basically I just need to read it again. And now if I run that, oh, let me see. Okay, first I'm going to check and see if that got changed. Okay, it did. Right, so that intron should be non-standard. Next, maybe I want to see if this grep-l is working the way I think it should. Okay, so that's working. All right. Let's check out the starts with. So that should come out to false. Okay. Okay, so I spent a couple more minutes staring at this, and my problem was that I was looking for the word intron in the sequence and not the header. Sometimes it's something really simple, like a mistake like that. Okay. Sometimes I have thought that I fundamentally misunderstand a language, and it's because I made a mistake like that. So if that happens to you, it happens to me too. Okay, so now if I fix that, yes, it finds that non-standard intron. So your last exercise for this video is I want you to take this expression and see if you can change it so it does exactly the same thing, but you're using an or in there somewhere. And the hint I'll give you is that you'll need to rearrange some knots as well. So try that out. See if you can use an or somewhere in there and have it work exactly the same. So you can do that in the Python version or the R version. All right, welcome back. Let's see how we would do that. Right, so I'm saying I want at least one of these things to be false, right, to give this non-standard intron message. So here's how I could change that. Again, what you should actually write in your code is what makes sense to you. So I think which makes sense is going to vary from person to person. Right, so I'm looking to see if it does not start with GT or it does not end with AG. So let's try that out and see if we get the same result. Yep, here we do. And we can change that here. Here we'll remove the not. We'll put a not before both of these. We'll change this one to an or. Right, so I'm saying, okay, does it not start with GT or does it not end with AG? So I'll rerun that function definition. I'll rerun it on my output and I see, yep, it still works the same. Okay, that was a long video for simple concept, but I wanted to really show you some practical ways to use it. So thanks for watching.